Hello students, in this video we will be discussing the various examples based on the concept of inertia followed by momentum. So as we have discussed in the previous video that inertia is the inherent property to resist any change in the state of rest or of uniform motion of an object. We also discussed that mass is the measure of inertia. More the mass, more the inertia, right? Then the example of inertia of rest. Now let me explain it to you with this example. Now the card is there and the coin is there, right? Now card and coin form one system, right? Both are at rest. When I apply force, right? When I apply force, what happens? See, the cord goes down, but the coin remained there in rest and hence it fell down into the cup. So why? Because coin said, you have not applied any force on me, why should I move? And the cord was under the action of an external unbalanced force, so it moved. Whereas the coin, which was not applied with any external unbalanced force, remained in the state of rest and fell down. So falling of the coin into the cup is example of inertia of rest, right? Whereas the moving of the card away is the inertia of motion. So it came from inertia, card came from rest to motion by the action of applied force. As there was no force on the coin, so it remained at rest and fell down. Similarly students, if you have a bruising over here and you have applied band-aid. Now band-aid and your skin form one system. If you will slowly and slowly remove the band-aid, your skin will be affected. What you do is you quickly remove the band-aid. Why? Band-aid and skin form one system. When you quickly apply force, then skin remains at rest, whereas band-aid comes in motion and it is removed. Then we come to inertia of motion. Now again see, if I tell you that this car is moving with a speed of 20 meter per second and you have to stop it, okay? That is, you have to bring it from inertia of motion to inertia of rest. So according to first law, we have to apply some external unbalanced force, right? Now if I tell you that this car moving with the same speed as that of yellow car and you have to stop this. So what do you think will be easy to stop? Red or yellow? Obviously the one with the smaller mass. So it again consolidates the fact that mass is the measure of inertia. So a heavy body, when moving, it has more inertia of motion. You require to apply more force to stop it and vice versa. Similarly, there are many examples like when you are sitting in a bus, right? Or in a car or in a train. So let us say this is the seat and you are sitting on the seat, right? Now the lower part of your body is in touch with the body of the car or the bus or the train. Bus and the body forms one system. So when body is at rest, bus is at rest, scooter is at rest, immediately it starts, your lower part of the body comes in inertia of motion, upper part remains at rest and you fall back, okay? And if in the same condition the bus or truck or any thing was in motion, then again the body was in motion. So body was in motion along with the car or the bus or the train and the brakes are applied and you will fall backward or forward? Forward. Why? Because now you were in inertia of motion. So on applying brakes, the lower part which was in contact with the car, bus, train immediately shared the force, came in inertia of rest but upper part remain in motion and you tend to fall forward. So that is why we have seat belts. Okay. Now we move to another concept, that is momentum. What is momentum? It is the total motion contained in an object. Okay. And it is product of mass and velocity of an object. It is a vector quantity and it is denoted by letter P, which is in small form, small p. SI unit is kg meter per second. Why? Because P is equal to mass and velocity, unit of mass kg, that of velocity meter per second. Hence, the SI units of momentum will be kg meter second raised to the power -1. Okay. Now, what is momentum? Momentum is product of mass and velocity. So it depends upon two factors. One is mass and other is velocity. Now it is a product. Now what happens if mass is 0? Mass is 0 means there is no object, isn't it? Because if there is any object, there must be mass. And if mass is 0, then 0 multiplied by V. So anything multiplied by 0 becomes 0. So there will be no momentum. So mass 0, momentum 0. I think you have understood. Now let us look into the other factor, that is velocity. Now velocity is 0. Then mass is 10 kg. So let us say 10 kg into 0 meter per second. So anything multiplied by 0 comes equal to 0. So for an object to have momentum, there must be some mass and there must be some velocity. Right? Now, the other thing is, let us say if mass is 10 kg, velocity is 2 meter per second, then momentum is 20 kg meter per second. Right? Now if the mass remains the same, P2, let it be 10 kg, but the velocity increases to 5 meter per second. So you see the momentum also increases. Now vice versa, if mass changes, right? If mass changes, P is equal to mv. In the previous example, we kept mass constant and we changed V. Now, we are keeping V constant and we are changing mass. So, let us say there are two cases, 20 kg into 2 meter per second. So, it is 40 kg meter per second. Okay, now we have to keep velocity constant. So, we have to keep it 2 meter per second. This is now variable. Another object with mass 10 kg. So, this will be having momentum 20 kg meter per second. So, dear students, momentum is, something which affects us a lot. Because if you are moving on a road and a big car is coming towards you, and then a small car is coming towards you, but the velocity is the same. So you will be moving towards this side because this is having less momentum. Now why? Because if the momentum is less, there will be less force acting on your body. Now how come? This we will be discussing in our next video. Till then, bye.